Assalamu alaikum students, this is class 10th and this is our third lecture. Today we are going to discuss about damped oscillation. In previous two lectures we discussed about simple harmonic motion, characteristics of simple harmonic motion and some examples of simple harmonic motion. And today we are going to discuss about damped oscillations. So first of all we define about damped oscillation. Damped oscillations, actually the damped oscillations are the oscillations of a system in the presence of some resistive force. These are the oscillation of a system. These oscillation stops after particular interval of time. So oscillation of a system in the presence of some resistive force are called damped oscillation. You know that ideal system, the system, those are ideal which do not have any resistive force. So those systems oscillate indefinitely. Ideal system vibrates in the absence of resistive force. They have no resistive force. So those systems oscillate indefinitely for infinite time interval. Those systems oscillate for infinite time, so they can never stop. So such process is not possible practically. Practically all systems have some resistive force, so they cannot vibrate for infinite time, so they cannot vibrate indefinitely. So we can say that no ideal system exists practically. Friction in practical system, friction reduces the mechanical energy of the system as the time goes on. In practical system, friction reduces mechanical energy of system as the time passes and motion is stopped. We say that our motion is damped, and such oscillation of a system are called damped oscillation. The examples of damped oscillation in our daily life, examples of damped oscillation are shock absorber. The absorber of an automobile, shock absorber of an automobile is one practical example of damped oscillation. And so shock absorber consists of a piston moving through liquid or oil. The upper part of the absorber is attached with the body of the car. When car travel on a bumpy road, the car oscillates, vibrates violently. So the shock absorber damped this oscillation and convert the mechanical energy produced due to the vibrations of the car into the heat energy of the oil, and the oscillations of the car will stop after some interval of time. So this is the damped oscillation. In this figure you can say that initially the amplitude of the oscillation is maximum, and as the time passes this amplitude of the oscillation reduces, and when time passes it going on reducing, and finally the amplitude of the oscillation becomes zero. This is the point where the vibrations of the car stop. So when damped oscillations are the oscillations under the presence of some resistive force. Practical system oscillates indefinitely, but ideal system doesn't oscillate indefinitely. They have resistive force, and resistive forces converts the mechanical energy produced due to the oscillation, and the process and the motion is damped. The shock absorber is one practical example of damped oscillations. Now we are going to our next topic, that is wave. In previous classes you discussed about wave. What is wave? Wave is simply, we say that wave is a disturbance in a medium. In previous classes in grade 6, 7 or 8 we discussed only about the wave, that it is simply a disturbance in a medium. Here we discuss some more about waves. Waves are the disturbance in a medium that propagates away and transport energy from that medium to other medium. Actually wave is an energy transportation mechanism. The disturbance in a medium that transport energy from one medium to another medium. Wave motion is a process in which wave transport energy from one medium to another medium. Here we move our types of the wave. There are two basic types of waves: mechanical waves and electromagnetic waves. Mechanical waves are the waves which require medium for their propagation, which require particular medium for their propagation, and mechanical waves cannot propagate without any medium. So we define mechanical waves simply as the wave which require medium for their propagation. For example, water waves, sound waves, waves produced in a spring. Sound cannot travel without medium. Similarly, water waves cannot produce without water. Then here water is a medium. Similarly, waves produced in a spring cannot travel without medium. So now we move electromagnetic waves. Electromagnetic waves are the waves which do not require any medium for their propagation. Examples of electromagnetic waves are X-rays, radio waves, television waves, heat and light waves. These waves do not require any medium for their propagation. Heat is also an example of electromagnetic waves. Light is also an example of electromagnetic waves, as light comes from sun, moves from space. In space there is no medium, so light is an electromagnetic wave. Similarly, heat comes from sun and it moves without any medium from space. So light is also an example of electromagnetic waves. Now mechanical waves further classified into two waves. Those are longitudinal waves and transverse waves. These are very simple. There is a little bit of difference between these two waves. Longitudinal waves are those waves in which the particles of the medium vibrate along the direction of the propagation of the waves. Longitudinal waves are the waves in which the particles of the medium vibrate along the direction of the propagation of the wave. The direction in which the waves move, the particles also move in the same direction. So transverse waves are the waves which vibrate perpendicular to the directions of the propagation of the wave. For example, wave move forward and the particles of the medium move vertically in transverse wave. In longitudinal waves, waves move horizontally and the particles of the medium also move horizontally. So in longitudinal waves, particles move along the direction of propagation of the wave, and in transverse wave, particles of medium vibrate perpendicular to the direction of the wave. Now we see some examples of longitudinal and transverse waves. In longitudinal waves produced in a cylinder, here we have a spring in our hand from here, and when we compress the spring a little bit, here we produce a compression in the spring. This is the direction of the travel, and here are the particles of the medium. When we produce a compression in the spring, these compression transfer energy to the next part of the spring, and here is rarefaction produced, and here again a compression is produced. So particles of the medium vibrate along the direction of the propagation of the wave, and the waves also move horizontally here, and the particles of the medium also move horizontally. So in this case, the particles of the medium vibrate along the direction of the propagation of the wave. So this is an example of longitudinal waves. Some other examples of longitudinal waves: sound waves, wave produced in oscillating. So longitudinal waves are one-dimensional wave. In this case, both the particles of the medium and the waves moves in the same direction, moves in same components of moves in a same direction. So they are one-dimensional waves. In transverse waves, we have a spring and we produce waves. In this case, here we can see that direction of propagation of the wave is horizontally, and the movement of particle is up and down perpendicular to the direction of the propagation. So direction of travel of wave is horizontal and the movement of the particle is vertical. So particles of the medium vibrate perpendicular to the direction of the propagation of the wave. This is the direction of the propagation of the wave, and this is the movement of the particles. So particles of the medium vibrate perpendicular to the direction of the propagation of wave. So these are transverse waves. Transverse waves involve crust and trough. Crust is the maximum distance above. This is the mean position of the wave. So crust means the maximum distance above the mean position, and trough means the maximum distance below the mean position. So some other examples of transverse waves are water waves, or waves produced in a string. So they are two-dimensional dimensional waves, they involve two-dimensional motion. The particles of the medium vibrate perpendicular to the direction of propagation of the wave. Here we see some similarities of longitudinal and transverse waves. Similarities are both are mechanical waves, both transport energy without transfer of matter, and both waves follow wave equation. These similarities and the differences between longitudinal and transverse wave is one important question occur in exam. So you must have to learn this topic. If you have any problem regarding this lecture, you can ask me in comment section. I will also provide you the notes of this lecture in web portal. You have to learn all the questions in given in notes. If you have any problem regarding the lecture, you can ask me in comment section. Thank you so much.